Let us understand Kubernetes as a platform. So if I compare a platform with a car or with a vehicle, then Kubernetes can be imagined as the engine of that vehicle. So as you see, this is an engine, and this is one of the key components of a vehicle. I mean, you cannot imagine a car or a vehicle without an engine, right? But only an engine is not sufficient for the vehicle. So the vehicle has other components also, which can be modular or flexible, just like exteriors. So I can have exterior of my choice, like material, color, shape, size. All these things can be chosen by individual or by the manufacturer who is manufacturing the car. Similarly, I can choose wheels of my choice, like any specific wheel grip, alloy wheel or spoke wheel, right? Seating, like I can have normal seats, I can have more comfortable seats, or ventilated seats, or any variations in seating. And there can be other add-on features that that can be accommodated with this vehicle, and this whole thing combined can be called as a car or as a vehicle, right? So everything together is called a complete vehicle. Similarly, Kubernetes is only the core engine and in the platform. I mean, it is not a platform by itself. So to convert Kubernetes into a platform, you need something more, right? So what are those things? Those things are mainly CRI, CNI, and CSI. So CRI is container runtime interface, CNI is container network interface, and CSI is container storage interface. So just like in the case of a vehicle, you can attach exteriors, wheels, seating, and other features, other options with the engine and make a complete vehicle. Here, Kubernetes gives you the flexibility to choose the CRI, the CNI, and the CSI of your choice from several available options in the market. Along with these three components, there are some other add-on features that should be used, like for some monitoring solutions, logging solution, performance, authorization, load balancing. How will you do all this? So by default, Kubernetes doesn't have any of these features. So there are many options available in market for monitoring tools, for logging solutions. So you can integrate any of the solutions with Kubernetes. And when all these things are integrated together, it is called a Kubernetes based platform, okay, or generally called as PaaS in cloud terminology, platform as a service, because generally Kubernetes has been used as a PaaS. Now let's understand this in detail. So this was the whole picture which we were trying to understand. Kubernetes only schedule and run the containerized workloads in the form of pods. This engine here in the core. The main ability of Kubernetes is to schedule pods and to run your pods. So pods, what are pods? We will just discuss it in the next module. Okay. For the sake of this slide, just understand pods and containers are same thing. Okay. Just understand this right now. Almost same thing. So Kubernetes schedule and run your containers in the form of pods. And by default, Kubernetes is unable to establish communication between containers or to provide storage to your containers, to provide runtime, okay, to provide monitoring, to measure their performance. By default, Kubernetes is unable to do all these tasks. So these components should be installed separately, okay? And Kubernetes provides interfaces for networking, for storage, and for container runtime, but it does not solve them directly. That means it provides you interfaces to integrate any solution of your choice which are already available in the market with the Kubernetes engine, so that you have network connectivity between your pods, a storage backend for your pods, and the runtime of your choice for your pods. Also the add-on features. So instead, Kubernetes allows you to configure a webhook to implement this functionality. And this integration is comparatively easy as compared to traditional integration with the software platforms. So basically, Kubernetes gives you the flexibility to choose the CNI, CSI, and CRI of your choice from several available options in the market.